Thank you. Welcome to Optimizing for Fast Flow of Value with Adaptive Socio-Technical Systems. And I give you a little bit heads up because I have the tendency to cover a lot of content in my talk, but I will provide a link at the end of the presentation to my presentation. And I am also feeling very honored to be part of Vaughan Vernon's Signature Series. Also, some authors of the Signature Series here are present as well, like Henry Schwentner as well. And so I'm writing a book about this topic in case you're interested to explore more. So when building systems in general, we are facing the challenges between building the right thing and building the thing right. And building the right thing addresses effectiveness and addresses questions such as how aligned is our solution to our user needs? And are we generating value for our customers? And have we understood the problem? Do we share a common understanding? And building the thing right, on the other hand, focuses on efficiency, for example, efficiency of engineering practices. And it's not only crucial to generate value for our users, but also being able to deliver that value to our users. And how fast can we deliver changes? And how fast and easy can we make a change effective and adapt to new circumstances? And the one does not go without the other. But Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated, doing the wrong thing right is not nearly as good as doing the right thing wrong. Or say it more in John Cutler's word, a little bit shorter, crap delivered quickly is still crap, unless we learn something from it and we can act on that learning. So to build the right thing right, we need to build adaptive socio-technical systems that are optimized for fast, sustainable flow of change and constant feedback. And one approach out of many that I would like to share with you today is combining Wardley Mapping, domain-driven design, and Team Topologies as architecture for flow. And we can start with creating a Wardley map that is visualizing the landscape an organization is operating and competing in. And a Wardley map is part of Wardley Mapping, a business strategy framework invented by Simon Wardley. So who of you have heard of Wardley Mapping before? Great. And who of you have created a Wardley map as well in your day-to-day business? Roughly 33.45%. That's awesome. So, and a Wardley map itself that emphasize to start with the users first. And starting from the user perspective, that aligns very well with the goal of building the right thing. Clayton Christensen, the inventor of the jobs to be done theory, stated that people buy products and services to get a job done. So in order to help users to get their job done, we need to know who our users are and what jobs they want to accomplish. So we need to identify the desired outcomes as user needs that the users want to achieve when getting a job done. And the jobs to be done and the user needs that we have identified, these are addressing or describing the problem space, and they remain the same however we are going to solve it in the solution space later on. So let's use an example of an online school solution for junior students. The users of the online school solution could be the teachers, the junior students themselves, principals, school administrators. But to keep it simple for this presentation, let's focus on the teachers only. And the teachers, they have the core functionality to facilitate remote learning. And to accomplish this job, the teachers need to prepare learning material, assess students' understanding with assessments and quizzes, assignments, and track the users' progress along the time, facilitate communication with the students, and ensure and set up a secure access to the learning platforms, for example, through sign-up and sign-in processes. And in the solution space, those user needs are directly or indirectly fulfilled by a chain of components that is generating value for the users by satisfying these user needs. And that's where we can blend in the value chain, the y-axis of a Wardley map, where the users and the user needs, they are then representing the anchor of the map. And deriving that value chain ensures that we are addressing the right problem and create value that aligns well with the user needs that we have identified. And the value chain also shows how these components connect in order to generate value and visualize the dependencies between these components. And when we create a Wardley map, we can start simple. So we can start with one user, and we can start with just a few components and iterate later. So in the example of the online school, the teachers are interacting directly with an online school component that is most visible to the users, to the teachers, and they are located at the top of the value chain. And this online school component is depending on other components, for example, the foundational infrastructure components, and they are less visible to the teachers, and they are placed further down the value chain. And those components of our value chain are then typically mapped to evolution stages from left to right, from genesis with brand new things, custom build, product and rental such as off-the-shelf products, open source software solution, and commodity and utility of the right, at the right. So in each evolution stage come with different characteristics. So towards the left spectrum, towards genesis, these components are changing far more frequently than components towards the right spectrum, towards commodity and utility. And on the left, we are dealing with a high level of uncertainties, unknown unknowns, an undefined, poorly understood market, while on the right spectrum, the components come more stable, mature, known, widespread, standardized, industrialized, and the markets are well-defined and mature. And we typically create this Wardley map in a group, and while creating or having a conversation while we're creating this Wardley map, that generates a common understanding of the landscape we are operating in, and also helps us to challenge our own assumptions. And the map also helps to identify areas where to invest or to innovate, and also where to evolve and where to outsource in order to gain competitive advantage. And I also use this Wardley map to assess our current flow of changes. So to build the thing right, now we are switching from building the right thing to building the thing right, we need to optimize for flow of change, for fast flow of value. And for that purpose, we can go along the dependencies in our value chain and analyze how a change would flow through our system. For example, when introducing a functional change, we can analyze what components along our value chain might be affected following the dependencies in our value chain, and then also address what team do own these components that are involved in that change. And also, how do the teams depend on each other, need to communicate and coordinate to make that specific change effective. So by assessing how a change would flow through our system, we can also reveal potential blockers to flow. And for example, by analyzing what is preventing flow along the value chain from various perspectives. So from an architecture point of view, or from an architecture perspective, we need to analyze how the parts in our system, in our software architecture, are coupled together. So in the example of the online school example, the component itself has evolved over time into a monolithic big ball of mud with a messy model and no clear modular boundaries. So Joseph Yoda, the previous speaker, he coined this pattern of big ball of mud. And a big ball of mud leads to tight change coupling. And tight change coupling impedes the flow of change itself, as changes in one part of the system has unpredictable side effects on other parts of the system, and also introduce the risk of breaking changes, of breaking things, and also introducing defects that we have to rework on. Another perspective that we can bring in is the team ownership perspective. So coming from our big ball of mud, a messy architecture with blurry, fuzzy boundaries, they make it very difficult to establish clear ownership boundaries. So that leads to a lack of ownership, which decreases then accountability, and which potentially leads to a not my job syndrome. And that can also cause decision delay and impeding our flow of change. And with business logic mingled together in a messy model with no clear modularity, that also increases the mental effort to understand a piece of code, and also including a mental effort, increase of mental effort to grasp the dependencies in a large, entangled, intertwined system. And when teams own too many parts, or when teams own too large, entangled parts of the system, their team cognitive load potentially exceeds. And when the team cognitive load is largely exceeded, it also becomes a delivery bottleneck. Another perspective that we have to bring in to assess our flow of change is the team dependencies. So we need to analyze where the teams depend on other teams' activities and tasks to get their work done. So do the teams have to repeatedly hand over work to other teams at a later stage of flow to get their work done? So the teams of our online school solution, they are currently organized as functional silo teams. So implementing and releasing functional changes from front end to back end requires to hand over work from the UI back end to infrastructure teams. But handover requires a high amount of communication and coordination efforts between multiple teams, including and also affecting our flow of change. And that also includes the potential risk of waiting times. And if teams are missing specific capabilities and need to bring in people, external people beyond the team with specific expertise into the team to get that they do something to get our work done, then it can also impede our flow of change, particularly, specifically, when those people aren't available when we need them. And teams can also depend on external decisions, for example, from management, or they need to wait for approvals so that they can't progress with their own work, to complete their own work. So every dependency requires some level of communication and coordination effort, and increases also the probability of waiting times and delays. And particularly when the people or the teams that we depend on are not available when we need them. And also when the teams that we depend on, if they are on high demand, the other teams can become a bit constrained, and then also slowing down the overall performance. So if teams have to interact with many other teams to get the work completed, that is a potential candidate for slowing down our flow of value. Another aspect of building the thing right is also assessing our efficiency gaps. So if the evolution stages of the components we use in our organization differ from the ones that are available in the market, that might indicate an efficiency gap. So one example could be, or question that we can ask ourselves, are we custom building components that do not belong to our core domain and where equivalent ones are available as product or utility in the market? Or are we using components in our organization as off-the-shelf products where, for example, equivalent ones are available as utility? So a common scenario is on-premise, running on on-premise infrastructure versus using cloud-hosted services. So when we have an efficiency gap, then we are potentially lagging behind in terms of efficiency, and this is especially crucial, especially when our competitors building up their value chain on top of better evolved components. So the blockers to flow that we have currently identified, we can unlock them by combining Wardley Mapping, domain-driven design, and team topologies as architecture flow as one approach out of many. So we can go back to our previously created Wardley map, and we can use this as a visual tool that steers us through the optimization. So to optimize for flow of change, we first need to analyze what will drive value and change within our organization. And what we have that requires to identify where the most important changes in our system occur, the streams of changes. And the user needs of our Wardley map are good candidates of customer-driven streams of changes. So we need to structure our teams and system around these customer-driven streams of changes and ensuring a fast flow of change where it matters most. And the user needs are not only representing the anchor of our Wardley map, but also representing the problem domain, and that's where domain-driven design can come in. So domain-driven design helps us to gain a shared understanding of our problem domain and helps us to partition our problem domain into smaller parts, the subdomains. But not all subdomains are equal. Some are more valuable to the business than others, so we have different types of subdomains. The core domain, that is the essential part of our problem domain, providing competitive advantage, and that is the subdomain we have to strategically invest in most and build that one in-house. The supporting subdomain, they help to support the core domain and complement the core domain offerings. So they do not provide competitive advantage, but are necessary for the organization to succeed and are typically prevalent in other competitor solutions as well. So if possible, we should look out for buying off-the-shelf products or using open source software solution for supporting subdomains. And if this is not possible, we come to that one in a second, then if we have to custom build the supporting subdomains, we need to be aware that we should not heavily in that part of the system because it does not provide competitive advantage. And generic subdomains are subdomains that many business systems have, not only on our competitor solutions, but every other kind of business system. For example, subdomains of generic subdomains could be authentication, registration, payment, and so on. So they aren't core, they provide no competitive advantage, but businesses cannot work without them. So buying, using off-the-shelf products, open source software solution, or outsourcing to utility suppliers, that could be applied to the generic subdomains. So the subdomain types help us to identify areas where we should focus our strategic investment and where to support us with where to build, buy, and outsource components of our value chain. So far, we have discovered our subdomain types, and we got an understanding where to focus the development investment. But when we switch to the solution space, the solution of our subdomains are currently all mingled together in our monolithic big ball of mud with messy models and no clear modular boundaries, which is causing tight change coupling and lack of clear ownership, high team cognitive load, and also we also identified an inefficient focus of our development effort on non-differentiating parts that could also block our fast flow of change, as we have assessed earlier. To mitigate the blockers to flow and to decrease inefficiencies, one aspect could be to consider to leverage modularity with high functional cohesion and loose coupling, and by designing a modular, well-encapsulated, loosely coupled system. And that requires to decompose our monolithic online scope component into modular components, and that brings us to bounded context of domain-driven design. A bounded context groups related business behavior together. So, and the bounded context defines where a single domain model can be applied and encapsulate particular business logic. And it's a bounded context itself, or bounded context in general, they are enforcing high cohesion and modularity. And they are indicating good domain-specific themes to split our system into smaller, modular, well-encapsulated parts. And they also serve very well as ownership boundaries. And we come back to this when we're addressing the team perspective. And designing bounded context and domain models involves the close collaboration between domain experts and development teams to gaining a shared understanding of the domain. And there are different techniques available, such as to design bounded context and domain models. For example, event storming from Roberto Barandolini, so he has given a workshop at this conference, or domain storytelling from Henning. He has also given a workshop here as well. Example mapping, user story mapping, and much more. So when we, at this stage, we have discovered our subdomains and we were able to design modular bounded context. So now we are able to better target our strategic investments. So, and for example, in center then our major development efforts around our core domain-related bounded context that is providing competitive advantage and that we need to build in-house. And for the non-differentiating parts, we need to evaluate whether we can leverage existing solutions in the market. For example, the generic subdomains related bounded context of identity and access for sign up and sign in, they do not provide competitive advantage, but they entail some common standardized processes and functionalities that require little to no variation or little to no customization. So here we can leverage existing solutions and, for example, existing off-the-shelf products or utility services. And for the supporting subdomain-related bounded context, the decision whether to build or buy is a little bit more nuanced. So the supporting subdomains, they are not core, but they play a significant role in supporting the core domain. So in our example, we have evaluated a couple of existing solutions in our market for our supporting subdomains related bounded context. But we maybe came to the conclusion that those existing solutions fell short and they would require a high level of customization. So that could, for example, then justify custom building supporting subdomains when we don't have equivalent solutions in the market ready or that require a high level of customization. And in a lot of cases, it's not only a binary solution, either build or buy. It's mostly kind of like a hybrid decision in terms of build and buy, where you build the part that is not covered by the off-the-shelf product, and to keep the off-the-shelf product as it's designed for use cases, and then custom build those parts where that is more aligned to your problem domain. The next aspect to consider is whether we can leverage better evolved components than we currently use in our organization. So that would help to increase our efficiency. And in our example, we decided to migrate our on-premise infrastructure components to cloud-hosted services that are available as commodities in order to close our identified efficiency gap. So far, we have unlocked blockers to flow that are related to software architecture and efficiency gaps. But we also need to consider the socio-technical aspect of our system. So that's where we also need to bring in then the team perspective and unlock the blockers to flow in regards to team dependencies and team ownerships and interaction between teams. And that's where Team Topologies can help us with their well-defined team types and the well-defined interaction modes. So who of you have read the book Team Topology that was published in 2019? Yeah, 50% I would say, awesome. So one of the team types are the stream-aligned teams, and the autonomous cross-functional stream-aligned teams, they are aligned to a continuous stream of work, focusing on a fast flow of change. But to be able to produce a steady flow of feature delivery, to be able to focus on a fast flow of change, those stream-aligned teams need to get support from other teams, for example, from the platform teams. The platform teams, they support stream-aligned teams delivering their work, and they are responsible for platforms that the stream-aligned teams can easily consume. And the platform itself can vary its levels of abstraction. So at a lower level, a platform can abstract away infrastructure and cross-cutting networking capabilities. At a higher level, a platform can also abstract away a design system, a data platform, and more. So the platform teams, they provide internal self-service services and tools that for using that platform that the platform teams are responsible for. Or the streamline teams can get support from the enabling team. So they work as internal coaches in the organization, and they help to identify capability gaps and upskill the streamline teams on those capability gaps. Or they can get support from the complicated subsystem teams. These is an optional team types, and they are supporting the streamline teams on particularly complicated subsystems that require very specialized knowledge. And they all aim for increasing the autonomy and reducing the cognitive load of the streamline teams to enable a fast flow of change at the end as an overarching goal. But to arrange these teams into these team types is not enough to become effective and efficient. How these teams are interacting with each other and when to change and when to evolve the team interaction is also very crucial for organizational effectiveness. So Team Topologies comes with 3 different interaction modes. So with collaboration, the teams are working very closely together over a limited period of time, and that is very important. The collaboration is meant to be short-lived. And for example, this is the collaboration interaction mode that is suitable for rapid discovery and innovation, for example, when exploring new technologies together between multiple teams. In X as a service, that suits well when one team needs to use a code library or component, an API or platform that can be effectively provided by another team as a service. And that works best where predictable delivery is needed. Facilitation, that's the 3rd interaction mode. This interaction mode comes into play when one team would benefit from active help from another team. So this interaction mode is very typical for enabling teams. So coming back to our Wardley map, we use this as a common ground for our discussion. The next step could be finding suitable team boundaries that align to customer-facing streams of changes. And as I mentioned earlier, bounded context serve as well-defined ownership boundaries, and that makes bounded contexts good, besides being good candidates to split the system into modular components. They also are good candidates for team boundaries for streamline teams. And to mitigate our previously identified blockers to flow that relates to team ownership, we also need to optimize for team cognitive load. And to optimize for team cognitive load, we have to limit the number, size, complexity of software system a single team has to work with. And this brings us back to the evolution stages of a Wardley map. So according to the characteristics of the evolution stages, the further left a bounded context or a component in general is located towards Genesis and custom build, the higher the level of uncertainty is, which then requires practices focusing more on exploration and discovery. And components in Genesis tend to change far more frequently, as I mentioned earlier, than components on the right spectrum towards commodity. And for components in commodity, we can draw on best practices, providing a clear path to action. And each evolution stage addresses different practices for their related paths to action, ranging from best, good, emerging, and novel practices. And as a heuristic, the more unclear the path to action is, the higher the team cognitive load can result. So that means that a single team could take ownership of more or larger bounded contexts or components that are residing in commodity on the right than in Genesis and custom build on the left. Another aspect to consider to optimize for team cognitive load is to establish clear responsibility boundaries. And for clear responsibility boundaries, we need to assign each bounded context to a single team and not share bounded contexts across multiple teams, because that would then diffuse their ownership of teams. However, one team can own multiple bounded contexts. In that direction, it's possible. So to be able to focus on a fast flow of change, as I mentioned earlier, the streamlined teams, they are relying on other teams supporting them delivering their work so that they can focus on a fast flow of change. So, and they, for example, rely on platform teams providing platforms that the streamlined teams can easily consume in order to reduce also their cognitive load. And that requires to identify services that support a reliable flow of change and can be easily consumed as a platform, which is then providing self-service capabilities. In our example, the infrastructure-related components of our Wardley map located in the commodity evolution stage, they are good candidates for forming a platform that can be effectively provided by, as a service by platform teams. And providing self-service capabilities that aims to make the cross-functional streamlined teams self-sufficient and eliminates the dependencies, the blocking dependencies of handover, and decreases the corresponding high communication and coordination efforts between multiple teams, and also decreases waiting times. So when talking about team dependencies and ownerships, we can also switch from the external customer-driven product view to the internal team-driven platform perspective, where now the teams become the users. And there we can derive its own value chain from the platform perspective. So switching to the platform value chain, that makes now the streamlined teams become the users of the services that the platform teams provide. And the streamlined teams, they have the user needs of provisioning and managing infrastructure, building and testing, releasing, deploying, operating, monitoring the services or bounded context they're responsible for. And to fulfill these user needs of the streamlined teams, the platform teams can provide a variety of platforms that the streamlined team can easily consume. For example, the streamlined team needs an infrastructure platform that allows them to provision and manage their infrastructure spanning components like from compute, storage, networking, security components, and more. And in general, the platform, whatever type of platform you provide, it can start small. It can start with just documentation. It can start with standards or best practices, templates, and can evolve later into a digital platform with self-service APIs and tools. And a built-in release platform supports then the streamlined teams to build, test, deploy, and release the services, and can build on top of other components such as version control system, CI/CD pipeline, test automation. And as I said earlier, a platform can vary this level of abstraction. At a higher level, a platform can also abstract away a design system that helps to achieve then a consistent, well-defined visual language at scale. And the platform team owning that design system then can provide style guides or standardized design principles, widget libraries, and more. And to operate and monitor a service, the streamlined teams then require dashboard, alert mechanism, incident management, and observability capabilities. And these capabilities can then be provided by platforms, by the platform team as operation and monitoring platform. So the platform team can provide, the platform teams can provide a variety of easily consumable platforms that satisfy the user needs of the streamlined teams, that make them self-sufficient at the end in supporting them delivering their work so that they can focus on a fast flow of change. Another aspect to consider for optimizing for flow is to identify and close capability gaps. And that's where the enabling teams can come in. So the cross-functional autonomous streamlined teams, they need to cover a wide range of capabilities such as software design and architecture, application security, user experience, accessibility, QA, testing QA, software development, of course, and it's a lot to cover. And where the specialists of enabling team can then can be pulled in on demand to upskill the streamlined teams on missing capabilities and to make them self-sufficient so that they can focus on the fast flow of change. And the enabling team is not restricted to only streamline teams. It can also facilitate platform teams by coaching them about how to, for example, improve developer experience for the platform that they provide, or they can or how to design a scalable, reliable, secure platform. And also the enabling teams can coach the streamline teams and the platform teams also on skills that are related, for example, on product management, which is applicable to both for streamline teams, but also platform teams, because platform teams now provide internal products to the streamline teams. But also effective communication, good documentation, and improvement of practices, such as team coaching, mentoring, and so on. So enabling teams facilitate as internal mentors and coaches and help to upskill then the streamline teams so that they become self-sufficient, which unlocks then the dependencies on people with a particular expertise to do something before the team can complete their work. So this eliminates this blocker to flow. But enabling teams also blend beautifully into the concept of learning organizations. And learning organizations, they embrace continuous shared learning and experimentation. And continuous learning and experimentation, that is crucial for adaptability, and that's so that we are able to respond to complex situations, to new circumstances with unknown unknowns. And in the context of the architecture for flow, continuous shared learning is supported by enabling teams that aim to identify and bridge capability gaps on the one side, helping them learning missing skills and to make them self-sufficient. Or it can also be supported by the short-lived collaboration between multiple teams to explore and rapidly discover uncharted new domains together. Or it can also can be supported by the close collaboration between development teams and domain experts in order to create a shared understanding of the domain as an essential part of domain-driven design to align the software design then to the business needs and to the business strategy. And in addition, this can also be complemented with other team learning methods. For example, establishing a community of practice to exchange knowledge and develop expertise on a regular basis with a loosely coupled team or virtual team. So, but we also need to consider that not only skills or capabilities are relevant to compose our teams, but also the preference and mindset of the team members. So when composing teams, Simon Wardley suggests to think aptitude and attitude, which means not only the skill set, the aptitude is relevant, but also the mindset, the attitude. And dealing with components in different evolution stages requires different mindsets. So Simon Wardley introduced explorer, villager, and town planners mindset or attitudes, formerly known as pioneers, settlers, and town planners. And my take here is that a mix of mindsets should exist in each team. And depending on the evolution stage, a particular mindset is more prevalent. For example, teams owning components in Genesis or custom build, they might tend towards an explorer mindset, which was a preference for discovering and exploring uncharted domains. Teams owning components in product and rental might prefer to improve and stabilize with a villager mindset. And teams owning commodity and utility components might prefer to mature and optimize with a town planner mindset, so that this mix of mindset allows you to respond in different situations and different ways, so that a team also owning commodity components can also switch to exploration modes, for example, when exploring new technologies together. So this architecture for flow approach helps us to unlock a variety of blockers to flow in theory, but the question is now how to put it in practice and how to transition into the target architecture for flow. And we can transition with a team-first approach as a reverse Conway maneuver. So Conway's law states that an organization designs systems that mirror their own communication structure. And the reverse convey maneuver suggests to restructure the organization to achieve then a desired architecture. And we are going to apply this very briefly in a very simple version. We are going to apply this reverse convey maneuver through incrementally dynamically reteaming and in small incremental steps involving the team interaction along the transition process. So optimizing our system for flow of change is led by dynamically reteaming our functional silo teams into platform and streamline teams in an incremental manner. And we are evolving their interaction along a cloud migration journey. And the transition could start with forming a platform team first that kicks off the replatforming cloud migration journey. And with replatforming, the on-premise infrastructure components are going to be incrementally replaced with cloud hosted services while we keep the existing application architecture the same. So we are not touching that one during our replatforming journey. And once we have completed our replatforming journey, we can then, the next team, streamline team, can form. And the streamline teams then, they take care of now refactoring the application. And with refactoring in the cloud migration, as a cloud migration strategy, we are splitting the existing application architecture into smaller parts, and that's where we can use the previously designed bounded context. And this refactoring journey is supported by an evolution of Team Topologies interaction modes. So the first streamline team can closely collaborate with the platform team at the beginning in order to assess potential cloud options that are applicable for the future bounded context that the streamline team is going to be responsible for. And this close collaboration then can evolve into limited collaboration on demand and eventually become then X as a service where the platform team provide best practices, standards, tools, or APIs in order to easily consume cloud services. And then the next streamline team can form and refactor their bounded context. And now we have blend in another interaction mode of facilitation. So this new streamline team can then get support as facilitation from the previous platform team and the previous streamline team, where they are sharing their knowledge and coaching them along their refactoring journey. And this can go on, and the next streamline team can form and get also support from the other teams, sharing their knowledge and experiences and coaching best practices. So that we are, with this reverse convey maneuver, so there we are able to resolve our blockers to flow by a team first approach in an incremental manner and step by step. So that the summary, the combination of Wardley Mapping, domain-driven design, and Team Topologies that helps to generate sustainable value that is aligned to identified user needs. It helps us to unlock blockers to flow. It helps us to focus on development investments, on our differentiators, and providing competitive advantage. It helps us to close potential efficiency gaps and align our teams in evolving their interaction along the system we built and the strategy we plan. And it also helps us to establish a learning organization which embraces shared continuous learning and experimentation and exploration so that we are then able to respond to new circumstances, to explore complex situations with unknown unknowns in uncharted domains. So this combination provides a powerful tool set to design, build, and evolve adaptive socio-technical systems that are optimized for fast flow of sustainable value and fast constant feedback that can thrive in the face of constant change and helps us to build the right thing right in the end. And we do not have to stop here. We can also continue, and we are now in a position where we are able to not only respond to changes introduced by others, but now we are also in a position that we are now can impact the landscape to our benefit and to apply strategic actions that others now have to respond to. So for example, creating additional differentiating value, providing, increasing our competitive advantage, being the first mover of commoditizing a component that others can innovate on, or by building cooperations and alliances with others, so to grow our ecosystem. So now we are able to drive future future changes. I also shared some resources that is going to be also involved in my slide deck. And as I mentioned, I'm writing on a book. And thank you so much for your attention.